Alright, I'm recording. Hi guys, so what is, how do you pronounce this actually? Riot?
Got it right.
Riot, okay. So you're like non-conformist kind of kernel programmers, right? Yay!
Yeah.
So what is Riot?
Riot is like an operating system for very small energy
Efficient.
energy efficient devices. Yes. It's very, very low resources. We targeted at systems which are too low power to run Linux. Because Linux can do most of everything you need to, but it doesn't fit on the really small things. Maybe I can show you one. Like these. They can
Oh
run
my god.
They can run for like 2 years on a battery, like radioing away their data or something.
So this device can literally work 2 years on a battery running a full-fledged operating system of some kind?
Yeah, well, it won't do much in these 2 years, but it's so power enough to document this. And Riot is made for these kind of devices.
What kind of device is that? Where can it be used, this Riot thing? In what devices can it be used?
Well, everything you have around in your home, that's the idea. It's the Internet of Things. So you have like maybe a washing machine, coffee machine or something. That's like one of my favorite examples. For example, I have an iPhone or something, or any kind of mobile phone, and I have an alarm clock on it, and it's internet connected. So I could like make my alarm clock wake up the coffee machine and the washing machine. So when I wake up, the coffee is ready, and after that I can like do my laundry.
All right, that's interesting.
So the bigger term is the Internet of Things. So it's connected devices, and we are targeting an end-to-end connection. So we are not focused on cloud-based solutions. We think that the Internet of Things should be based on open standards like IPv6, UDP, things you already know.
Yeah.
Things that integrate in your existing infrastructure, and we want to provide some basics that your own business or your own idea or your own campaign, whatever you want to do, can have a basis for that. Because if you're starting from scratch with an embedded device, it's if the complexity gets bigger and bigger, you will have problems. The complexity will kill your project, and perhaps you don't want to write an operating system. It's not a simple task, and you can plug us in. You can focus on your application, and we have the basics to run Riot on your device. You just need to provide the basic drivers. So if you have your special hardware, you have to write the drivers. We have all the interfaces, and then you can use our scheduler, our IPC, message-based IPC, all the features we already have. So.
Okay, so as you mentioned before, this is kernel. Do you have any userland software with it?
Right. We have like network sticks, schedulers, IPC, timers, everything you need to start like a basic embedded application. But because it's embedded, you can't really talk about userland because there are no users like really directly working on the system. It's more like you put it on a device which has maybe some physical controls, but it's supposed to be on like very for example, a washing machine. It has some controls, but you don't really need userland for that. But we have lots of libraries that help you actually do some service coding.
All right, maybe word userland was not an appropriate term here. But my point is, if there is something small, something awesome, people will want to abuse it. Okay, probably the best example would be Raspberry Pi actually. If there is something small like that, they will probably do all sorts of crazy stuff with it. My point is, existing C++ applications, providing that they are small enough for the device to actually be able to process it. Will it be possible to port it, or maybe it does not even require port, but it will work natively, or?
Well, that's the idea. It's probably rather easy to port it because we try to be as close to, for example, Linux coding. And so usually every simple C code should just run. C++ code, there's some support as long as it doesn't use. With C++, there's a problem that most C++ code uses a lot of the C++ standard library, like the libstl, and that's very large, very powerful, very large. And we are like targeting this. For example, this has maybe 50 kilobytes of RAM. It doesn't fit on there.
So in other words, if it's C-like code with no additional libraries but standard libraries, it should pretty much work, yeah?
Yeah. So if your code is, for example, C99 compliant and is just using standard C, lib standard C features. So like we have a standard libc. So on the ARM platforms we have new libc. But you can plug other C libraries in. So as long as your target platform has enough memory to run it, we can provide the infrastructure. So we are actually we have a very nice make system which is able to only compile the stuff you really want. So if your application, if your idea doesn't need a full-featured IPv6 stack, or doesn't need no routing, or I don't know, some features we have, and you just don't compile it in, and it's not in your final binary. So we managed to have this great make system.
Can your system be virtualized?
Yes, we have a native port. We call it the native port, which means you can run the Riot kernel and the application you're developing on like a Linux system as a process. And then you have user space for thread switching, and you can use all the API, but it runs as a thread on Linux.
So we compile this embedded operating system into one Linux binary. So there's from the Linux perspective, it's just a thread running there in the userland, and but inside it's complete Riot with its own scheduler, with the message API, with everything you have on your embedded device. Plus on the native port, the big benefits are that you can use your normal Linux tools to debug. So you have we managed to integrate Valgrind support. So it's pretty amazing to use Valgrind for embedded development. And for the networking part, if you want to develop network protocols, we have TON-based solution that if you're compiling, you have your Riot compiled for your Linux, it will use a virtualized network, and then you can use Wireshark to debug this stuff. So it's a complete operating system in a box in a Linux process, and from the Riot side, there's no difference in where it runs. It runs completely well in the Linux process.
Actually, we see that as one of our biggest advantages. Like you can write code for Riot, write it on Riot, and you use the Riot APIs, and it will probably run on every Riot supported hardware that you get. For example, you can run it in the native port on the Linux system. And like, we have MSPA2, which is an 5-phase board. Then we have a little watch here.
This is what was going on. My next and probably last question: if there are any actually devices implemented with this thing.
Yeah, you see like 2 or 3 here.
Tell me what this watch can possibly do.
Well, as you see, it's a watch. It has a display and it has 5 buttons.
Okay.
What we have here is a little demo. We call it like, I don't know, it's like some kind of alarm system. This is a thing, it has 3 states. It's like this, or on the side, or on the way up. And over there, you see the LEDs, and you can see that if you like, if you change this, it
position?
will change. So if you change the position, you have the 3 states here.
These LEDs.
Okay.
They are connected using a multi-hop wireless network, which they organize themselves. If you turn them on, bam, they find some kind of topology and can send data over it. This is
can they be used in mesh networking?
Yes, it's mesh networking.
Absolutely.
All right.
It's a wireless ad hoc mesh network.
Okay, good.
And you see the topology here. For example, now if I change this, you can see visualized where the packets go. You see, for example, we have the sensor node here, we have the LED node here, and we have our gateway or web server here. This is the we call it web server, and there's a gateway node connected to the web server on the V2. So
this is very interesting that you can possibly use this thing as mesh networking. I mean, this is in my opinion, this is what this world needs. We need more mesh networking because, especially in places like United States of America, where right now there's a big issues, you might have heard of it about the Netflix and stuff that's going on there.
Yeah.
So we need meshes, guys.
Yeah.
If you can create something good about it, make it reasonable.
Yeah, we will bring mesh into your home.
we mesh your buttons.
All right.
So the technology we use is we implemented a subset of IPv6 and low power adoption for 6 low band, and as a routing protocol we have here running RPL. So all these nodes are just starting up. There's no pre-configured gateway or something you have to do as the owner of it. It's just starting up and then searching for Ripple network, so on demand searching for it. And then this portal node here, it's configured as a root node in the topology, and it will send out these Ripple root announcements. And all the other guys are joining in, and it's the way we think the Internet of Things should work. So
all right.
Our data rates will not be made to stream Netflix over it. So it's a different domain. It's definitely a different domain.
Hey, who knows? Maybe in 20 years, that might be a real possibility, eh?
We will see.
What about this watch that you were showing me? It's so interesting. What is it so? Are there any special features on it, or is it just a standard watch?
No, it's not a standard watch. It was the Texas.
Does it get you? The most important question: does it get you laid?
Look at it, of course.
It will show the
You have a
time.
button which you can connect to the internet. You see, I press the button here and something on the internet happens.
So this has a wireless transmitter inside.
Yeah. And it is running Riot. It's running our operating system. So I think Riot.
And using this specialized low energy hardware that you were talking about earlier, I'm guessing this is one of this kind of hardware. How long those watches would actually operate without being recharged?
Good question. Wie lange hält der Akku?
Just curious.
Depends on what you're doing.
Days.
Days. Okay, days.
Well, this has a
Fair
really
enough.
small battery.
But we expect that these kind of devices will get big impact.
Optimized, yeah. I mean, I understand.
So all these
this is like
smartwatch
like
communities. So yeah.
My good guess is that this kind of devices in the future, this kind of watches in the future, if it goes mainstream, it might survive far more than a few days, I'm guessing.
Of course. And this is just the development kit made by TI. It's not made for like.
Yeah, so it's not even mainstream yet. It's not even been sold or anything like that.
So
Okay.
we see these Pebble watches and stuff coming up from Kickstarter. And we will see more other products which will come up for the Internet of Things and try to connect everything. And we hope that we can be a part of it and provide the lower layers like Linux does. We are here in Linux Tag.
Which is not exactly Linux, because you're actually going against mainstreaming here. You're actually a competitor to Linux, but it's always good to have a good one.
But we don't see ourselves as competitors.
Oh yeah.
We target only platforms that are not able to run Linux. So
that brings me to another question. Why not optimize Linux kernel?
Well, you see, this thing has 10 kilobytes of RAM.
Okay.
Try to optimize Linux down to 10 kilobytes of RAM. It's like just impossible. But the need for only 10 kilobytes of RAM makes it possible to run it only here with the battery. I mean, there are watches this size that can run Linux for a day.
Yeah.
I think they use this because
Yes.
they don't want to recharge my watch. So if you want to have the battery life, you need to scale down the system. So make it really low power. Linux cannot do that.
So right now, are there actually any products that are mainstream that are being sold using Riot? No, not yet.
Not yet.
Is it stable? Can you consider it to be stable at the moment?
Of course. It is. It's
Why?
mostly lucky.
Why you were so scared when I asked this question? Of course.
Well, because stability is always slowly. I would call it stable. It's stable enough for you to start a project with it and use it back.
and we did Riot in a way that we have the core, so just the basic features, the scheduler, the IPC, which we concern is very stable. So we tested it on every possible platform we can get.
That has lots of testing. We started it like 5 years ago and tested it.
And
So the core is stable, the API is mostly stable, and there are obviously some bugs in some network code. Yeah, there will find bugs, but I think it's stable. I would use it.
All right, fair enough.
And all the other code is just optional, and of course it will. Some parts of Riot will not fit on every hardware because yeah.
What? I'm not sure if I've asked this question or not, but what type of license are you guys using with this?
We are using LGPL version 2.
AGPL, okay.
Yeah. The idea is that everybody can write proprietary software and ship it out as a binary, but we want all the changes made to Riot, we want to force them to give them back.
Something similar to GPL3, I suppose. I'm not familiar with AGPL. I've heard this word a few times today.
LGPL makes it possible to link like your own code to Riot, but under whatever license you want. But so you can ship, like you can link it to Riot and ship it, but you don't have to provide your own source code, like the source code of your own application. With GPL version 3, that's impossible. If you link
with
it to
GPL3
Riot,
impossible, but with GPL2 I think it is.
No, with GPL2, not even that. You need LGPL for the link. That's what the lesser general.
Okay. All right. Thanks a lot. It was really interesting, and I think people are gonna appreciate that. Thank you.
I think so. Bye, thanks.